let's solve for that exact angle that fulfills both requirements. So you're given that the tangent of angle theta is 2/3 and the angle is in quadrant 2. So I'm a visual person. So if I start over here, right, and I'm going to go to quadrant 2, right? It doesn't have to be exact. But basically, you're going to get a triangle right here, and you're solving for this unknown angle over here. So you're going to form a triangle where this terminal point meets the x-axis. So now I'm going to draw that triangle literally as I see it, where we've got angle theta in quadrant 2, and the tangent of angle theta, well, remember, we go back to TOA. The tangent of an angle measures the ratio of an angle's opposite to its adjacent side. So the top part is the opposite, the denominator is the adjacent. So if the tangent of theta, right, is 2 over 3, that means that the opposite side of angle theta is 2, and the adjacent side of angle theta is 3. So we've got a triangle that looks like this. So now that we know that the tangent of theta is equal to 2/3, how do we solve for angle theta? Well, in order to undo a trig function, we need to do the inverse trig function on both sides. So I'm going to do that. So the tangent inverse gets applied to both sides of the equation. So now the tangent inverse cancels out with tangent. And now the theta, first things first, are we in degrees or radians mode? We are in degrees, cool. So we need to do the tangent inverse of 2/3. And that would be 33.690 degrees. So round to the nearest 3 decimal places. 33.690 degrees. Okay, but that's only the reference angle, because your calculator only understands angles between 0 and 90 degrees. Remember, we're in quadrant 2, so if the theta is 33.690 degrees, we want to figure out the arc of this black angle in quadrant 2. So in order to figure out the Q2 angle, remember that this black angle plus angle theta creates 180 degrees. Well, if I want to solve for the black angle, the Q2 angle, I need to subtract the red reference angle from it. So 180 degrees minus 33.690 degrees, that would mean that the quadrant 2 angle is approximately, let's see, 180 minus 33.69. So that'd be 146.31 degrees. And how do we check our work? I would check with the ratio given. So 2/3 would be 0.66666666 repeating. So let's take the tangent of 146.31, and that would be 0.66666666 itself, but we are in quadrant 2. So I should have said right there in the beginning. So yeah, in other words, we're in quadrant 2. So this quadrant 2 angle is 146.31 degrees. Okay, so that takes care of problem number 1. Let's move on to problem number 2. The tangent of angle theta is 7/3, but we are in quadrant 3. Okay, so I start over here on the right side. I'm in quadrant 3, so I'm going to end up in the bottom left. So I'm going to draw a picture of this quadrant 3 angle. Remember, I sandwich it with the x-axis of the base. So the terminal point ends here, and the angle theta forms when I sandwich it with the x-axis of the base. So I can form a right triangle by dropping it down so that the triangle looks like this. Okay, so now I've got a 90-degree angle, and remember that tangent of theta is equal to 7/3. So according to my diagram, the opposite side, so TOA, that means that the opposite side over the adjacent side is 7/3. And if theta is in the corner, it's not drawn to scale, I apologize. I know that this should have been way longer, so you know what, it's going to drive me insane. So it's going to look like this. Okay. So if I have a 90-degree angle here, and this is angle theta, the opposite side of angle theta is 7, the adjacent side of angle theta is 3. So I want to solve this triangle if the tangent of theta is 7/3. So what we need to do is undo the tangent by applying tangent inverse to both sides. So I'm going to apply tangent inverse to both sides. So that the tangent inverse of tangent of theta cancels out, leaving me with angle theta, and it's going to be an approximation. So let's do the tangent inverse of 7/3 in the calculator. The tangent inverse of 7/3 is 66.801 degrees. But remember, that's only the reference angle. So we want to figure out what the entire arc is, that black arc as opposed to that red reference angle. So in other words, remember we're in quadrant 3. So if this is 66.801 degrees and this arc is 180 degrees, well then together they would form the quadrant 3 angle. So the quadrant 3 angle is equal to 180 degrees plus 66.801 degrees. And that would be approximately, well, if 180 plus 60 is 240, then we've got 246.801 degrees. And we can check our work by comparing the 7 divided by 3, which is 2.33333333. And you know what I can do? I can compare that to the tangent of 66.801 degrees, 2.333327, so pretty darn close. And I'm going to compare that to the tangent of 246.801 degrees. Yeah, and remember, it's between 180 and 270, so yeah, it's in quadrant 3. Okay. Problem number 3. Last tangent one. The tangent of angle theta is 6/11, and we are in quadrant 4. What is that particular angle? So remember that quadrant 4 is in the bottom right, specifically between 270 and 360. So if I were to draw a quadrant 4 angle, it would look a little something like this. And we want to sandwich this terminal point with the x-axis of the base. So that angle theta has to be right here. So specifically, I'm going to form a right triangle as we sandwich the terminal point with the x-axis of the base. So this is what my triangle is going to look like. Sorry, let me just make that a little bit more realistic. Okay, sorry about that. It's not drawn to scale, but you get the idea. So we're going to draw an angle theta, and remember that the tangent has an opposite and an adjacent part. So the opposite has to be 6, the adjacent has to be 11. So we've got 6/11 for my triangle, and I'm trying to solve for this angle theta. So now I've got the tangent of angle theta is equal to 6/11. And in order to cancel out the tangent to get to angle theta, I need to apply the inverse trig function on both sides. So now the tangent of angle theta is equal to 6/11, where I apply tangent inverse on both sides. Tangent inverse cancels out with tangent, leaving me with angle theta is approximately what? Let's apply the tangent inverse on both sides. So the tangent inverse of 6/11 is 28.610 degrees. 28.610 degrees. But remember, that's only my reference angle. So I'm going to use my knowledge of reference angles to solve for this entire arc. So remember that if we add the black arc to the red reference angle, we should get 360 degrees. Well, if we want to solve for the arc and we know the reference angle, why not just subtract it from 360 degrees? So the quadrant 4 angle is equal to 360 degrees minus 28.610 degrees. So let's do that. 360 minus 28.610. So that would be 331.39 degrees. Approximately. So therefore, I can check my work by comparing 6/11 with the tangent of 331.39. Yeah, pretty identical. Okay, moving on to problem number 4. So the sine of theta is -4/9. And we're in quadrant 3. So now we're back to sine and cosine. Okay, well, if I look at my angle, I end up in quadrant 3, so it's going to be in the bottom left. So if I were to just draw an angle in quadrant 3, what kind of angle am I looking for? I'm going to sandwich the terminal point with the x-axis, creating an angle theta. Okay. So now I can create this triangle that looks a little something like this. So there's my 90-degree angle. Remember that my sine, cosine, tangent, so my sine ratio has an opposite side and a hypotenuse. So if my sine ratio is -4/9, well, I'm just going to assume that they're positive, because the reason why it's -4/9 in the bottom left is because the y-coordinate is negative in quadrant 3. So the sine ratio, we can just call it 4 and then 9 over here. So if we have angle theta in the corner, that means that the opposite side of angle theta is 4, and the hypotenuse of the triangle is 9. So I'm trying to figure out what this angle is based on this information. So the sine of angle theta is equal to 4/9. And in order to undo the sine function to get to the unknown angle, I need to apply the sine inverse on both sides of the equation. Because the sine inverse is an inverse function of the sine function, therefore getting us to the identity element. So therefore, sine inverse cancels out with sine, leaving me with angle theta. I'm going to apply the sine inverse of 4/9, and therefore that gives me 26.387. But remember that the fourth decimal place is another 7, so that rounds up to 26.388. But remember, that's only the by the way, degrees. That's only the reference angle. I want to figure out what the quadrant 3 angle is. So if I take a look, that the red reference angle is 26.388, I want to figure out what the entire arc is. Well, if this top half is 180 degrees and I add the reference angle to it, I bet you I get the quadrant 3 angle. So that'd be 180 degrees plus 26.388 degrees. So that means that my quadrant 3 angle is approximately, say 20 plus 180 is 200, and then 206.388 degrees, approximately. We can check our work by comparing the ratio that we're given, -4 divided by 9, -0.444444 repeating, and then compare that to the sine of 206.388 degrees, and we should get approximately -0.4 repeating. Look at that, pretty darn close. The more decimals you use in your angle, the more accurate your solution is going to be, but I think 3 decimal places is enough. Don't hurt yourself. All right, last problem, and then we'll call it a day. We'll have a test on Tuesday. I know today is Friday. I want to give you one more day of this, and then the test will be given to you, and it'll be due Tuesday. Okay, so the cosine is -1/5, and your angle is in quadrant 2. Originally it was going to be in quadrant 3, but I was like, oh man, that's another quadrant 3. So I just changed it. So I start over here at the 0 degree mark. Remember that I'm in quadrant 2, so I'm going to be between 90 and 180. So if I were to compare this, let's just say I draw an angle right here. I'm in quadrant 2, and my angle has to sandwich with the terminal point. So what I can do is create a triangle that looks a little something like this. Now I'm in business. Now I've got a right triangle in quadrant 2, and that's why the shape of my triangle looks like this. So I've got angle theta, where it should be, and my cosine, it's not drawn to scale, I apologize. My cosine, always helps me visualize. My adjacent side over my hypotenuse is going to be the ratio. So I've got 1/5. I know it's not drawn to scale, I drew it accidentally, where the adjacent side was longer than the opposite, but just bear with me. So if I've got the cosine of angle theta is 1/5, how do I undo the layer and solve for the angle theta? I'm going to apply cosine inverse on both sides of the equation. Because now I get cosine inverse of cosine of theta, well that cancels out, is equal to the cosine inverse of 1/5. So if I say I want to take the cosine inverse of 1/5, that is 78.463 degrees. But that's only the reference angle. I want to figure out what the, so I guess the angle would be a lot taller, and it'd be around here. I just drew a rough graph because that's the way my brain works. But I want to figure out what the black arc is. So if I'm in quadrant 2, and the black arc plus the reference angle is 180 degrees, well, I'm gonna say that the black arc is equal to 180 minus the reference angle. So the quadrant 2 angle is equal to 180 degrees minus 78.463 degrees. Well, I'm just doing my mental math. If 180 minus 78 is about 102, well, it's going to be 101 point something, so I'm just going to do it in the calculator. So that'd be 101.537. And if you want to check your work, you can check your work by saying -1/5 is -0.2. And I'm going to check my work by taking the cosine of 101.537 degrees. Look at that. Pretty darn close. And that's why the diagrams look like they do. All right, we're going to have one more day with this, and then we'll have a test due Tuesday. Have a great day.